Hey everybody, welcome to Data Engineers Lunch number 4. We are part of Data Wranglers DC. We used to have a monthly meetup, which got paused by COVID-19, and we started this up recently to meet weekly and talk about data engineering and data wrangling. Today's topic is airflow for data engineering. Will Angel is actually a member of Data Community DC. He's a board member, and excited to have him talk about how he's been using Airflow. Akwi and I are co-organizers. I wanted to give a special shout out to Akwi, who helps record and produce the videos that get on YouTube, as well as the blog posts that have a collection of all the notes that we're going to talk about today. Always looking for people to help get new members, speakers, sponsors. I mean, right now we don't really need monetary sponsors, but if you get sponsors that can send t-shirts and stickers and cool stuff like that, that'd be great. Data Community DC is a big supporter of diverse communities. We are a diverse community, always looking to get folks from different backgrounds, race, gender, sexual orientation, religion, all the different protected classes. If you know somebody that is underrepresented in the tech community, especially the data community, would love to get them to come speak about some topic. Well, as long as it relates to data engineering, data wrangling in our group. There are various groups as part of Data Community DC. We are one of them, and so feel free to go to the website datacommunitydc.org and check out things like statistical seminars, Nova Data Science, and pretty much all of these are online now, so you don't really have to go to Northern Virginia. Like, that's really across the river for me. I'm in DC. But I can now go there. What we cover here, we cover data wrangling, data engineering. It's really the middle part of taking raw data and getting it to be in a state which can be used by other people, primarily data scientists, data analysts, for either business intelligence, data exploration, for further processing and machine learning. And in some cases, it's actually the end product itself. It's an API that other people use in a partner ecosystem. So anything to do with data, in terms of moving data, processing data, we want to talk about it. Any technology comes up, we're not stuck to one language or another, or one technology or another. So Ben, as I promised, you'll have a moment to introduce yourself. Usually in our physical meetups, people would just get up and talk to somebody they didn't know. Well, most of the people here have come here before. Do you want to give a quick introduction to yourself? What brings you here? What do you do with data? What do you do with data engineering?
Yeah, sure. Can you hear me?
Mm-hmm.
Cool. Yeah, so Ben Malnor, I work actually at WMATA, and so I'm kind of doing some of the back end engineering, getting transportation data, so both bus and rail data, but focus so far has been a lot of bus data wrangling into a database that our planners and data analysts and the planning team can use. And we actually stood up a server internally, like on-prem server, for us to do some ETL on. And I've been thinking about using Airflow. And so when this talk popped up, I was like, hell yeah, all right, I want to learn about that. Like, it's been on my radar, but I haven't touched it. So I'm just curious to learn about that. That's it.
Great, that's awesome. Yeah, thanks for joining. And is there something that you could potentially tell us about, something that you could teach our group about?
I'll think about it. I think I'm still, this is my first time coming, so I'm not sure what the other expertise are in the group, and not sure what I can bring, but if I think of something, I'll definitely bring it to the table.
Awesome, great, thanks. Well, welcome, Ben, and looking forward to hearing from you. And Dan, you wanted to give a reintroduction because we just started this.
Yeah,
go ahead.
No, my name is Dan. I'm a database developer, mostly work with Oracle. That's about the long and short of it.
Okay, sounds good. Well, welcome again. Good to see your face. We'll get right into the meat of it. Group rules, if you have a question, you can ask it on the chat. If somebody doesn't acknowledge it, just politely, bring it up. In fact, it's not just that you can ask us a question during the middle of a talk, but it's also a place for you to add to the conversation. Just be polite about it. It's a conversation. It's a meetup of people. We are one of the sponsors. I am a principal at Anant. So is DataStax. They've been supporting us for a long time now. And as is GW University, great partners for Data Community DC in general. Hopefully they'll give us venue space when everything opens up. We have some local sponsors around the area, some co-working spaces, as well as a data engineering company out in Chicago, because we have been doing this now in Chicago and in DC. Organizational sponsors, these are folks that support the full data community nonprofit. Data Community DC is a nonprofit where companies can sponsor us and get a tax write-off. So, if you know anybody that would like to support the cause, it's great for advertising, as you can see. Capital One uses us to hire people all the time because this is how they get their name out there. Any announcements for related to data community, data engineering? Any meetups? I know, Bill, you had a couple last time. Do you have anything coming up soon?
I think on Wednesday there is a Statistical Seminars DC meetup, primarily on, I believe, data visualization. So that should be fun. And on the 16th or 17th, I'll clarify the date later, there is going to be a Data Ops DC / Data Community DC sort of holiday party. Nice. So I'll share details on that, but keep an eye out on meetup.com.
Great. Yeah, let us know. We'll put it out on our meetups as well. Yeah, this is Statistical Seminars DC. It's coming up on Wednesday. Statistical Seminars DC, as you know, is one of our data community members. Very cool. Well, thanks for bringing that up. We've got a couple. So obviously today we're doing Airflow for data engineering. There's one workshop that I'm giving tomorrow related to Spark streaming with Kafka and Cassandra. Shout out to Arpin, who's done a lot of the coding for this. This is a third in a series about event-driven toolkit, how to use events throughout a data engineering process. Generally related to data on Data Community DC, there's always events like the Statistical Seminars one, and then we just started doing this weekly lunch call. So if you're looking for more events, go to Data Community DC or Anant.us/events. And now I can hand it to Will, our presenter.
All right, excellent. Let me go ahead and share my screen. All right, can everyone see my slides?
Yep, yes.
Excellent. All right, so my name is Will Angel. I actually come to data engineering from more of a data analytics, data science background. And so I've really gotten into a lot of this because I want the data to be there. I don't want to have to spend, 80, 90% of my time making sure that the data is in the right place, that it's getting there cleanly. So I really like tools that allow me to get data in the right place and not have to worry about it getting there correctly. So today we're going to be talking about Apache Airflow, which is an excellent tool for orchestrating ETL jobs and similar tasks. So overview, I'm going to give a brief presentation of Airflow and then a demo. For the presentation, I'm going to be talking about what is Airflow, how it works, and why you should consider using it instead of other scheduling tools like Cron, Luigi. There are a number of others. And then for the demo, I'll give you a demo of how the tool actually works. I think for questions, feel free to either type questions in the chat, interrupt as we go, or save them for during the demo. And if anyone knows Airflow better than I do, which given this room, there's a good chance, please feel free to chime in. So what is Airflow? Airflow is an open source task scheduling tool that allows you to programmatically author workflows, primarily in Python, but from Python, you can call anything else, and you can then schedule and run those workflows using cron, cron tab notation. And then the real big thing is that you can monitor and log those results, which, unlike cron, is pretty large. So Airflow is split out into a couple of different components. The three primary components are the scheduler, which is really the core of Airflow. You've got the executors, which can either be local on a machine or as large as a like Kubernetes cluster, as large as you want. So it's very scalable in that regard. And then the third aspect is the web server, which provides a front-end interface and takes some of the load off the scheduler. And basically, what happens is you have DAG files, these workflow files, which are set up as graphs, directed at acyclic graphs in a Python file. And the scheduler reads those files, which all sit in a single folder, and then it schedules them, sends those to the executor services, which then actually run the tasks. Though if a best practice with most task scheduling is to have the actual task itself be external as well. So really you have the scheduler, which oversees a small fleet of executing services, which then actually coordinate with whatever runs the task and then does that. One of the pretty interesting and useful things is that you get a lot of information coming back from the executors, and they actually log it to all that metadata to a database that works for Airflow. You can either use SQLite or basically any database that you want. So yeah, the web server actually has a really useful GUI that basically allows you to do anything except for write entirely new workflows. And there, I'm sure that many of you have worked with a lot of tools and are very comfortable with command line interfaces and APIs, but for sufficiently complex tools, having a nice user interface allows you or other people on your team to interact with the tool in a very useful way. So one of the big questions that comes up a lot when discussing scheduling tools is, why not just use Cron? Cron is a standard tool in every Linux user's toolbox and makes it very easy to schedule a task to run. But there are a couple of areas where Cron does not shine, and a lot of that is around things like sleeping at night. If you've ever owned an ETL job that's used Cron, you've probably had it. You may have had it fail, or you may have had it push bad data, partially fail, and then you may have had to go and build email alerting and add logging, try and debug it. All of that is stuff that Cron does not do by itself, which means you need to either add that yourself, which usually leans towards developing your own logging framework for Cron, your own alerting framework for Cron, which that's a lot of extra work. And Airflow has native support for all of that. So for any specific workflow, you can add email alerting in a couple of lines of code. You can add logging in a line or two of code. You can add very sophisticated retrying, including configuration for how it retries, when, if you want to use exponential back off, things like that. And unlike Cron, if you do logging, the logging can happen remotely as opposed to showing up on the machine that is actually running that, which means that you can just integrate Airflow directly with any monitoring tools that you're using. The second reason is scalability. Cron is limited to a single computer, so you can get around that, but it starts getting really complicated. Whereas with Airflow, you can stick it on a Kubernetes cluster and get a lot more scalability, as well as the reliability that comes with that. That said, You also can run Airflow on a single machine and just have the improved logging and alerting without having to really get into any of the operations needed to support a Kubernetes cluster. You also have scalability, not just on the scheduling side, but on the workflow execution, where you can have a separate fleet of workers that actually does the execution, including a number of different types like Kubernetes, Dask, or Celery. Dask is really interesting for the data processing side, because if you have a Dask cluster, you can execute tasks on that scheduled in Airflow, that's a very powerful combination for doing data processing. So Airflow also can be extended and has a pretty big community, pretty big ecosystem, which means that there's a good chance that for a popular integration or popular data connection, someone's already written it and it just plugs it into Airflow very conveniently. Which also means that if you need something done, you don't have to try and build it custom from scratch. There's a good framework for how to build an Airflow extension. Whereas with Cron, you'd be looking at either a custom ETL job or a custom piece of software, messier, a little less support. So the real thing that, in my opinion, makes Airflow a much better choice than Cron is version control. DAGs are defined as Python files. All of them are stored in a single folder, and that means it's really easy to version control them. If you want to have version control cron jobs, you have to do version control on basically each file, which frequently are split in several places on a single computer. And if you have multiple computers running cron jobs, you have to do version control on each of those, and it just becomes something of a mess. So being able to have basically a single repository for all of your ETL jobs, all of your workflows, really allows you to bring a lot of software engineering best practices to task scheduling, which is very nice when you want to make changes and be able to roll back on a cron job, roll back on a workflow. The version control is really nice. So that said, Cron is still an incredible tool, and Airflow is not without its additional costs, its additional pitfalls. The first one is overhead. Airflow is a little bit more computationally intensive to run than Cron, and you actually have to stand up a full instance for it. That said, you get a lot more out of the box. So it's got monitoring, it's got logging, it's got alerting. All of that would also take extra. So it's not exactly a direct comparison. The second is maintenance. Airflow is pretty low maintenance. However, if you want to go down the custom extension route, you can make it as complicated and as hard to maintain as your custom extensions. But I think that's a fairly universal fault of any software that can be customized. And the third is complexity. Airflow is a relatively simple tool, but it makes it easy to do a lot of complicated things, which are all good things that we probably should be doing. Logging, monitoring, alerting, ETL version control, data lineage, all of that adds complexity. And with Airflow, it's very easy to build a sophisticated data processing pipeline, which is a good thing, but it means that you can get a lot more sophisticated and therefore a lot more complex than just Cron. So a couple of core concepts of Airflow. First is sort of workflows. And that's just a sort of conceptual idea of how to set up a task. And there are Python files that are set up as directed acyclic graphs, which just means that they're set up as nodes in a graph and they do not loop. So the first node will never be referred to by the second or third. It's all basically a tree structure. You then have DAG runs or workflow runs. And there the idea is a workflow being run is separate from the actual workflow object / file itself. And then inside that DAG run, you have tasks. and instances of those tasks are instantiated and then executed, and each of those tasks has a life cycle. A task can be queued, a task instance can fail, a task instance can be retrying, etc. And then there's the last sort of core concept, which is the idea of an operator. And that, in this case, that would be like a bash function, a Python function, a Spark job, some SQL. And there the idea is that an operator is the single smallest, most atomic unit that your tasks and workflows are built out of. So a couple of core questions, and these are just sort of more things to keep in mind around task scheduling in general. And I don't necessarily have answers to all of these, but they're questions that I think are worth asking ourselves. How do we define a task in a way that a computer can run it? And this is both a sort of practical question in terms of, what's the best way of structuring things, and a more philosophical question in terms of how computers actually work and some of the difficulties that entails. For example, the time-based scheduling actually gets really hard when you get down into the weeds, because computers don't have a concept of time per se. And our human concept of time starts getting really messy because computers expect everything to be fairly neat. So things like leap seconds, leap days, those can cause a huge mess. Time zones, etc. A more practical question, how do we know that a task is run successfully? That can be challenging in network conditions. I'm actually currently reading a really, really good book called Designing Data-Intensive Applications. And it is an excellent read and has made me far more paranoid about distributed systems and anything involving networks, because figuring out what's going on in a network can be very challenging. So if you have a database job or an ETL job that is reading data from one database and writing it to another, knowing when that has failed can be challenging. And then the second follow-up question is, how should you retry when something has failed? Because if you rerun an ETL job, I suspect some of you have experienced duplicating data because it actually didn't fail or didn't fail fully. So that's something that you want to be careful about. And then fourth is sort of, how do we keep track of changes in a recurring task? And that gets into logging and monitoring, as well as version control. And clearly I had a fifth thing to say, but it's not there. So if there are no questions currently, I'm going to jump into the demo, which I think will also make a couple of things more clear about the actual workflows themselves. We'll look at a few, which that way DAGs will actually, I think, make some sense. So I'm going to go ahead and switch screens. Did that work? I'm going to go ahead and move my screen over. Now, instead of the slides, can we see the the Airflow interface?
Yep.
Excellent. So this is the Airflow admin console. It's the web server, and it gives you a list of all of the workflows, all of the DAGs.
No, hold on, Will. We can see just your desktop and a like an Explorer window. We can't see the admin UI, I think, that you're talking about.
Let me retry that. How about now?
There we go.
Perfect. Thank you for that. All right. So yeah, this is the admin, the Airflow interface. And there it allows you to do basically everything that you would want to do in Airflow, short of actually writing the workflows yourself. And one of the things that it does really well is give you ways to visually see basically the entire status of a task, and then to drill down. For example, let's take a look at this Python example. And here we can see the tree view of the DAG. And you can see that you've got the sort of high level DAG, you've got the first step, and then you have all of the child nodes. And there you can then, for each of these runs, each of these columns here is a run, and you can see the status of each task with great details. And that's a filter. And so there, remember how I mentioned that there were a number of different task, statuses in the task lifecycle. These, the color here is based on those. So if something has failed, you can see it very quickly. If something is still running, you can see it very quickly. You can also see information about how long things take, as well as the ways in which things execute. I'm going to actually, I'll switch in a minute to an example that shows this even better. You can see the details of the task and filter that by whatever statuses you like. You can see the code itself. And this is a slightly modified example of one of the demo DAGs that that is included with the project. And here, it's a little bit strange because of Jinja templating, but this is Python. And so you define a DAG object and you give it an ID and a schedule interview or schedule interval. This syntax should look very familiar to anyone who's used Cron because it is the cron tab notation. So it's exactly the same. You just have to write a little bit more code around defining the entire workflow, but it's, I think not a lot more verbose than doing the same thing as a large bash script. So it's pretty convenient. You can also trigger jobs manually. I'm going to go ahead and queue this one up again. I'm going to trigger it, and now it's going to start running. Move the zoom out of the way. So I'm going to go back to DAGs and open up a more complex DAG. So this could be a more complex workflow here. If you've ever written a ETL job like this, you have my condolences. And here, this is an example. So a lot of things are failing as expected. And if we look at it as a graph, this starts getting pretty interesting. So you can see that you've got the first node and all the others. And one of the things that Airflow does really well is you can see what tasks failed. So in this run, for example, the search catalog task failed, and everything downstream of it that depended on it failed as well. So you can see that all these failed because they were blocked by the search catalog task. So I'm going to go ahead and go back and go to, actually, we're going to continue with that one. And you can see that the recent individual tasks, as well as the DAG runs, and you can see the status there, success, in progress, or failed. And for tasks, you can see the number of tasks that have succeeded, the number of tasks that are currently running, that have failed because of an upstream task, that were skipped, that are retrying, that are queued, etc. So basically, just in this one column here, you can see the entire life cycle of all of the tasks within a workflow that have been initiated. It's very, there's a lot of ability to drill down. For example, for this complex task that we looked at that we know is failing, we can go and just click on this, and we can see all of the runs that have failed. And here you can basically write filters. And in just a minute, I'll show you that you can actually write pure SQL against the task metadata because it's getting logged to a database. So you can write your own custom queries about tasks And so if we dive into this one, this is the specific task. And you can see again here that it's very quick to pinpoint what failed and when, which is, I think, much more pleasant than trying to dig through logs that may or may not have the level of detail you need to troubleshoot an ETL job. So I'm going to go back and go up to the logs functionality. And in this case, it's logging every task that gets run, every workflow, as well as all the details about it. You can even actually set up SLA agreements based on your time performance in any given workflow, and Airflow will actually monitor that. So if you have a job that your target is to finish it within 15 minutes or 15 seconds, you can write that into the workflow, and then Airflow will monitor that as well. So you can write SQL on the data, which is very interesting. So if you, instead of grepping your way through log files, you can write SQL against them, which is nice if you want to do things in a more programmatic way. Though I'm sure some of you who are more competent with Bash and shell scripting than myself can do some impressive things with grep in batch files or bash files. So I'm going to go back over here to the DAGs and want to pull up, I believe it was the example Python operator here, and go to task duration. Airflow will show you the number of tasks and how long they took within a job, which effectively allows you to monitor the performance of tasks within a job, which also makes it easier to troubleshoot overall performance. Say you have a job that usually is fairly fast, but sometimes slows down. Airflow has this built-in charting to show you the duration per task, which allows you to very quickly identify any anomalies that may be causing issues. So this is quite useful. You also can get a Gantt chart of what happened and when, as well as a sort of total consumed time of a job. So if you want to see which aspects of a job are taking the most wall time, you can see that here as well. I'm actually going to go, just to show the Gantt charts off a little bit better, I'm going to go back to this complex one, and here you can really see what the Gantt chart looks like in terms of what's taking the most time, what's happening when. Let me see, is there anything else I wanted to mention? Yeah, I believe that is everything I wanted to demonstrate today. Happy to take questions at this point.
Thank you. We'll appreciate the walkthrough. So I've got a couple of questions for you. What are some anti-patterns in Airflow that people should be aware of? Excellent
question. I think one of the biggest anti-patterns that people should be aware of is when authoring workflows, there are a couple of pitfalls around retrying things. For example, if you do anything that's non-deterministic in your workflows, for example, if you use a time function to get the current time, that if a workflow fails and has to retry, that'll be different the next time you get it. So being thoughtful about when your workflows are deterministic or non-deterministic is definitely one thing. The other thing, I think the real big anti-pattern that should be avoided is actually putting heavy workloads into a workflow. And so there, the best practice is to separate the actual the actual work. Say, for example, if you have a Python script that connects to a database, collects some data, transforms it, and then loads it elsewhere, there it would be, you want to keep that as a separate script and have the workflow call that script. If you have the workflow, if you have that data processing in the workflow, then the scheduler, then Airflow itself will have to do that work. But if you have it out as a separate script, it can be run separately, which makes things a lot more scalable.
There's a question on the chat. What are those alternative schedule representations?
The alternative schedule representations in terms of the scheduling here.
Obi, if you want to unmute yourself.
Yeah, that's what I was asking about.
Yeah. So these are the cron tabs. Oh, the alternative schedule representations in terms of like at daily.
Yeah.
Yeah. So I believe Airflow has support for additional types of scheduling notation. So it's not just cron. You also can make workflows trigger based, though I don't know how to actually do that. But you can make things programmatically trigger based off of external circumstances. Yeah.
Cool. So basically, just a follow-on question for what I asked earlier. Basically, don't do the E, T, or L in the DAG.
Right.
In your Airflow code. Do that elsewhere.
Right. So Airflow is not actually a data pipeline tool. It is a data pipeline scheduling and orchestration tool. That's, I think, the better way to think about it.
And what would you recommend as a complement in your experience that works well with Airflow for E, T, and L, or whatever, you know?
Yeah, well, SQL is my bread and butter. So I really like just using SQL. For the most part, I think any sort of standard processes work pretty well. But if you really need a lot of computing power, either something like Dask to scheduling tasks on Dask with Airflow, or switching to something like Apache Spark, which is also really good, and you can use Airflow to trigger Spark jobs. Or, well, you can have workflows that include Spark jobs.
Is there like a direct API that you use with Airflow to Spark, or you just run Spark submit or something?
Yeah, so Airflow does actually have an integration with Spark, as well as integrations with like all the big cloud things and a ton of third-party non-open source tools. You can also do everything programmatically in your workflows or in the scripts that they call. So if you can, if you would normally trigger a Spark job through the command line interface or like a Jupyter notebook, that type of thing, there you can pretty easily get Airflow to trigger those.
Cool. I have more questions, but I'll let
Go ahead. Just one question.
Yeah.
Spark, it is just triggering the job, or it will how it further happens, in the sense, if I'm just doing the Spark job as a client, okay, it will wait for that. If I'm doing it as a cluster mode, it submits the job and returns back the handler, correct? What happens?
Yeah, that is an excellent question. I actually don't know enough about the Spark and Airflow interface and that integration to tell you exactly what happens. But generally, at a high level, it makes it work and gives you the enough task lifecycle updates so that Airflow can tell if the job was successful or not and retry appropriately. But that is an excellent question. And I saw that we also had another question from Ben in the chat about the schedule frequency for cron jobs. And there, I believe Ben is correct. The most frequent cron job can be once per minute. And that is actually the syntax here, which is */1 ****, or once per minute. And there, Airflow is not an optimal tool if you want, very high frequency real-time data. Once a minute or every 5 minutes, every 15 minutes, that's sufficiently close to real time for most applications. But if you need something that's really high frequency, is really real time, Airflow is not the optimal tool for that. Though at that point, neither is Cron.
Yeah, that's a really good question. And I think either there's a guy who was here last week, David, or somebody else can talk about, event-driven processes, or maybe I'll do one. Yeah, real-time data processing is like a whole different world. And Airflow is not in that world. Airflow is in the batch world for the most part. You can possibly read data, right? Extract it, transform it, and instead of loading it to a database, you can fire off events to a queue, but then whatever is going to process that queue is not running in Airflow. I think like the one potential I would think about is having Airflow trigger the Spark Stream job to get started, just to monitor it basically, right? Just to make sure it's running. I mean, I think that would probably work. Or like if you have a Spring app, like people use Spring for stream processing all the time. It's just the service that runs and picks off events. So like, I don't know if Airflow is in that world of like making sure programs are running, but like, I guess you could kind of have a long running process where it's monitoring, right?
Yeah, you could certainly do that. And if you have issues with programs staying up, you could have a recurring workflow in Airflow that checks the status and takes actions to either restart it or do something else. Though in most circumstances, I would want to find a more robust way to make sure that process stayed up. Something like putting it on a cluster, but yeah, you could absolutely do that.
Any other questions?
Will, just one more query. In the I think in the workflow or something, you are showing each task. There was a which Gantt chart. Each task, against each task, we are showing some arrows. Those each task is a Python script, or what exactly how it is?
Yeah. So
Not
so this is
the other Gantt chart probably.
Oh, the Gantt chart.
Yeah.
Let me do that for one that actually should have something for the Gantt chart. Is this the one you're referring to?
Yeah. Here, if you look at data tag, template, field, create tag, all these are the Python scripts, or what?
So in this case, each of these are tasks that are defined in the workflow. And so here we can actually go and look at the code. For example, let's go and find the get tag template. So we can go and look at the code, and it's defining the DAG, and this is just the list of tasks. And so here we've got create tag, we've got get tag template, and here in this case, these are bash operators.
Okay.
And it's just got the task ID and a bash command.
Okay.
But each of these could be, you could mix in bash operators, Python functions, Postgres, SQL queries, basically anything.
Okay.
Cool.
Is there any future thing that you might have a GUI that could create new workflows with some template type functions or something like that?
Yeah, so one of the things that's really interesting about Airflow is that it has very good support for programmatic workflows as well as workflow templating. So you can basically build workflows and generate workflows using templates. I don't believe that they have plans for the GUI to include that, but there are some third-party tools that try and make that easier. That said, as far as future development goes, one of the things that we should be hearing about, well, it was originally scheduled for 2020, but I think there's some delays. Airflow 2.0 is going to be the next major release of Airflow. And so they're going to be actually adding a lot of additional features, as well as making it even more scalable. Because technically, even if you're running it on a Kubernetes cluster, the scheduler in Airflow is still the limiting factor. And if you take out, all of the other work from the scheduler, it's very scalable. Thousands, millions of tasks, no problem. But it does, that is the sort of limiting factor of the entire system's reliability. For Airflow 2.0, which should be coming out soon TM, they're going to a distributed model for the scheduler, which will mean that you can have multiple schedulers and load balance those and make the entire thing even higher availability.
Very cool. Jay has a question about performance benchmarks.
That is an excellent question. Jay, do you want to elaborate on what type of performance? Because one of the things that's challenging about comparing task schedulers is, I believe I mentioned this briefly earlier, is Airflow does a lot of things around logging and monitoring and alerting that have performance overhead hits. But as far as the actual tasks themselves, they're close to unchanged. For example, I guess one of the smallest possible workflows you could define would be a workflow that runs a single line of bash, a single command line, and the actual work itself, the actual running the line, would be the same amount of work. So for the actual tasks, there's no extra work. And for most instances, the added overhead of Airflow is really more about the time than the cost and the compute overhead. For example, if you put Airflow on a medium EC2 instance, you should be good unless you're working with some really complex workflows.
Yeah, I think just to kind of chime in, Airflow is not really in the performance world in that it's just like Jenkins. Like, what makes Jenkins better than GitLab CI/CD or Travis CI/CD? How much computing power do you have? Nobody's gonna be like, well, this one's written in C++ and this one's written in Python. Like, nobody gives two shits about that, right? In Jenkins world. So that's kind of, I think, where my thought is that it's not, the only thing I think you would compare in terms of performance is like what you were talking about, Will, Airflow 1 versus Airflow 2. What is the scale? Jay's talking about NiFi. I don't think NiFi is comparable to Airflow. This is not, NiFi is a tool that I think Airflow could use to trigger things in or to do stream processing in, but correct me if I'm wrong, Will, but NiFi is a different class of software, right?
Yeah, Airflow is not, it's not data streaming. It's not it's not data processing. It's the scheduler and orchestrator for all of that. So it's sort of not quite the correct comparison, but yeah, it's certainly always good to be mindful of performance. And one of the downsides that I mentioned of Airflow is it is a more complicated solution. You're adding another tool to your stack, whereas with Cron, it's built into every Linux virtual machine you have. So yeah, in short, there I'd say the performance is not really a huge concern, and the way that you write your workflows has a bigger impact on performance, because if you're writing really complicated workflows, you still have to write like OK code and actually have some reasonably well thought out ETL jobs. If you're doing cross joins on select stars, you're going to have a bad time no matter what's scheduling and running the tasks. But as far as the reliability goes, like I said, Airflow basically gives you all the monitoring and reliability for cron, cron type scheduling, so that you can sleep at night. And Airflow 2 is going to add more features so that your ops guy can sleep at night, not worrying about whether Airflow might fall over.
Yeah. You actually just put something in the backlog, maybe to find a speaker or to talk about Apache NiFi for data engineering, because it's a really fascinating technology for fast data processing. And it's really interesting because it has internal to its engine, it stores data in like Lucene. And it's able to route data because it's able to like tokenize that information pretty quickly. But I think like I look at Apache NiFi as a class of software that I would compare with, I think like Kafka Connect, for example, where you have data coming in and let's see. So Jay, if you have the ability to unmute yourself if you have a question. I think he just sent some links, which I don't have any context of what you're trying to say. Workflow graph, blah, blah, blah. Oh, I think, yeah, so he sent a thing here in terms of like, what is Airflow doing, which is a workflow graph. But again, this is the code that runs in NiFi is potentially processing the batch or it's processing the items of the data itself. Airflow does not do that. Airflow just runs the command that runs elsewhere. Like you could use Airflow to run a NiFi process or a Kafka process or a Spark process, but Airflow itself doesn't handle any of the data. Yeah, just to kind of clarify that, it's a different tool. I would say like, if I were to compare, Spark, which is you can do everything with Spark, Airflow is not Spark. Yeah. I think it makes a little bit more sense for people. Like Airflow is very similar to Jenkins in that, it's calling other things to do the job. Like Jenkins has a dependency tree, right? Like compile this package, compile this package, compile this package. If this one fails, you can't compile this like downstream thing. So go back and fix your thing first, and then it'll compile the next one, and then it'll deploy it to Docker, and then it'll whatever do its job. Or like Spinnaker for Kubernetes. Again, Spinnaker doesn't write your software, right? It kind of like builds it. It builds it for you. But that's a really good question, Jay. Just trying to understand like what is Airflow about, and I think Airflow is it's in that whole DevOps, data ops, right? Yeah. So like he just mentioned on here, like Airflow plus Spark job server. Yeah, or you can use Airflow and Apache Livy, for example. Right, Apache Livy gives you a REST interface to Spark. You can also use that, and then you get your. But you still have to do your programming for your Spark jobs in Spark. But what he brings up, what Jay you bring up, yeah. So, all right. So I'm going to stop having a conversation with chat for a second. So basically, Jay mentioned, yeah, you can always call in Jay. The phone function actually, it fixes audio issues generally. But Apache Livy is like basically a REST server on top of Spark. So technically, you can use Airflow DAGs to call REST APIs that are doing the job. And I haven't checked recently, but Airflow probably has like a provider for REST. So like to say, go run this thing and then come back. Actually, I'm putting this also into the backlog. I've got a list of items that are interesting. So like Apache Airflow to trigger REST workloads or something, because that's actually like people have webhooks, right? That they expose and say, hey, I want this thing done. And even though the webhook says I got it, it may take like 10 minutes for it to finish the job. So awesome, yeah, thank you so much for the questions, Jay. I appreciate it.
Yeah, those are great comments. And I think one of the things that I've emphasized is Airflow is great because it gives you monitoring and visibility so that you can start figure out where to debug performance issues in ETL jobs and the like, which that is a whole nother topic that I'm sure we could spend many days on, if not many hours on.
Yeah, absolutely. All right, I will take back the controls to just show people kind of what's coming up. Let's see.
Oh, it looks like there's someone else you need to introduce.
Oh, he's been here before. It was just a little late, that's all. So we have, as I said, there's a hands-on workshop, Spark streaming with Kafka and Cassandra. All of the hands-on stuff will be done in Gitpod. And Gitpod is essentially like a Visual Studio Code environment in the cloud, and you don't have to set up anything on your laptop. The repo is already up. We're doing a final check of everything on the dev branch. But basically shows you how to set up an API in Cassandra, how to set up Kafka for stream processing, and then how to use Spark to then also augment what is being done in Kafka and Cassandra. It's supposed to be a deep dive boot camp into understanding event driven for data processing or just building platforms. So that's coming up tomorrow. As always, there are events coming up on Data Community DC. Feel free to check that out. We also have a backlog of topics that if you'd like to present on something that's already on this backlog, or you want to present on something different, please leave your email in the chat window and Akwi can schedule you for one of the following Mondays. So Jay, actually, I would love for you, I know you're a super duper expert on Spark, so it would be kind of cool for you to talk about Spark and like alternative schedulers like Yarn and Kubernetes versus Spark standalone. Because somebody said, yeah, here we go. Anatomy of a Spark ETL job, right? Like how do you write one? So I'd love to have different folks present. Will, thank you so much for joining us today and presenting. I've got a couple of other Airflow topics. So if you have a follow-on presentation on Airflow, maybe in a couple of weeks. I don't want to turn this into an Airflow meetup, but I know it's awesome. I really think it's really great technology.
Maybe one of these years.
Yeah, I know, right? When you find this guy named Free Time, let me know. I'm looking for him too. All right, folks, it's 1 o'clock. Thanks so much for joining. We'll see you, same time, same place next week. We'll put something on the calendar. Take it easy, folks. Enjoy. Thanks again, Will.
Thank you for
Yes.
Thank
your
you.
presentation. Thank you.